Okay. So in television transmitter, you have to transmit the audio signal and video signal synchronously. For this purpose, there is a combining network which will combine the audio signal and video signal in proper instance of time. After combining the signal, it is given to the transmitter antenna for transmitting the signal to the worldwide. So before the combining network, so you have to take the video as well as audio separately, where audio is to be frequency modulated and video is to be amplitude modulation. So for audio, you require a microphone which will convert the sound wave into electrical signals. Then it is given to a audio amplifier for increasing the amplified signal. Then it is frequency modulated. Then it is given to the combining network. For video signal, the television camera is kept in the television station to capture the programs. Then it is signal is amplified by video amplifier. Then it is amplitude modulated signal. So it is amplitude modulated. So it will given to a power amplifier for increasing the power. So this is the block diagram of a television transmitter. Next one, television receiver. So in the television receiver, we have sent the information in the transmitter. Now we have to receive the signal. This television receiver may be, the antenna may be in your house, or if you are putting a cable connection, then the antenna will be in the cable operator home. So the antenna will receive all the signals. The antenna will receive all signals. So RF tuner is a circuit, so which will tune the television to a particular channel. So RF tuner will tune the circuit to a particular channel. So RF as tuners. So RF tuner will select a particular channel. Next one is common intermediate frequency amplifiers. So intermediate frequency amplifiers are kept, which will amplify the intermediate frequency. Next comes video detector. So that is for comparison purpose. So this video detector will detect the video. Detect the video. If the video is good, then only the video detector will send the corresponding video. Here also you have scanning and synchronizing circuits because the video has to be transmitted in a proper fashion. For this, synchronizing is very important. There is a circuit available in the CRO which will do the scanning and synchronization. Similarly, after detecting the video, the remaining thing will be available is sound. So sound amplifier, IF amplifier. Next one is sound intermediate frequency amplifier. Then you have to demodulate the sound. So you have to remove the frequency modulation. Then it is given to an audio amplifier for boosting the voltage, and it is given to this mount. So this is the arrangement for the television receiver. So in the television you have a loudspeaker. It may be a single loudspeaker or double loudspeaker at the side. Or you may have a single loudspeaker at the bottom. Okay. So next one is picture tube. So picture tube, it is connected by all the circuits. Mostly it will be used to display the video signal. Okay. So what is inside the picture tube? So you have to see what are the components inside the picture tube. So picture tube is used to make a screen visible. There is a phosphor coating coated on the surface of the screen. There is a phosphor coating on the surface of the CRT screen. Okay. So when you hit a object on the screen, it will display. Okay. This is the principle. So here, for making the image to be displayed, what we are doing is we are taking the image, taking the image. Hello?
ஸ்க்ரீன் விட்டு இல்ல அதே அதுல இறங்கி குழுக்கணும் ஒரு பாக்ஸ்ல போட்டு.
Hello?
ஒண்ணு 40 ரூபாயா தெரியல, 30 ரூபாயா தெரியல, 30 ரூபா நினைக்கிறேன்.
Mohammed.
Tell me clearly.
ஜூஸ் போட தெரிஞ்சாலும் கர்நாடக அவ்வளவுதான்.
Sir, you can remove or you can able to mute his mic, sir.
வாழ வச்சாரு எங்க அத்தா நடந்து போயிட்டு இருந்த பைக்ல ஒரு பொம்பளை குண்டு வச்சு வந்து அப்படியே வருது. பார்க்கவே இல்ல, பக்கத்துல கொண்டு வந்துட்டான். என்ன சாவ போறியாடி, போடி போய் சாவடி சாவடி கத்தாரு போய் சாவடி அதுவும் அது யாரும் போ போ அங்க போய் சாவு போ போய் சாவடி போடி. வேற வந்து குறுக்க வந்து விழுகுறா அந்த பொம்பளை, பயந்துருச்சு. எங்க அத்தா கண்ணாமண்ணான்னு போடி அங்க போய் சாவடி போடி திட்டி விட்டாது கிளம்பி. என்ன சாவ போறியா, போய் சாவ அங்க போ. யாரு
Sundar sir, voice.
Hello? கேக்குதா?
இப்போ கேக்குது சார், இப்போ
Hello?
கேக்குது. இப்போ ஓகே சார்.
Okay. Okay. So these are the connecting pins. So we have to connect these pins to the socket where the electric voltage is given. It is only a base for mechanical support. There is a heater coil. So here, due to this voltage applied, this will heat it. The temperature will increase here. Due to the increasing temperature, the electrons will be emitted. So these electrons will flow in all the directions. To control the flow of direction in a particular direction, we are using the control grid. When you are applying a voltage here, it will narrow down to a particular direction. This accelerating anode is used to increase the speed of the electron beam. So this will convert the electron beam. This will increase the speed of the electron beam. Next one is focusing anode. This will focus the electron beam on a particular point. Here the electron beams are splitted, so we have to make it as a single point. So for this purpose, this focusing anode is given. Next one is this final anode. So this will send the electron beam to make dots on the screen. This will help you to make the electron beam to display on the screen, not in the sideward, not in the this area. So for this purpose, this final anode is given. There are deflection coils, horizontal deflection coils and vertical deflection coils. These coils are used to move the screen points from left to right and top to bottom. So in a TV, so what is happening is we are seeing an image. It is not a full image. It is every single dot. Okay. So this single dot, so it will move continuously very fast. So starting from left to right, top to bottom. For a single second, this dot will move 625 frames per second. So 625 frames means, so one screen is known as one frame. For a single second, this electron beam will move from top to bottom 625 times. That much speed it will move. So for us, it seems to be an image, but that image consists of several dots. It is only a single dot. So in image processing, we are telling the name as pixel. So it is a single pixel. So all the single pixels combined together, we are seeing an image. So this speed is very high, so that we cannot assume that it is moving. We assume that it is a standstill image. But actually, this electron beam is moving 625 times from top to bottom for every second. So this is about monochrome TV transmitter and monochrome television receiver. Okay. So this picture tube also monochrome TV picture tube. So what is monochrome means? It is black and white TV. So some persons have seen this black and white TV. So it has only two colors, either black or white. So there are different levels of black and white mixed, and some colors other than black and white can be seen. It is of gray level. Okay. So these three things are related to black and white TV. Next we are going to see color TV. In color receiver, the circuit is somewhat complex when compared to a monochrome TV receiver. Here also you have an antenna. This antenna may be a dish antenna or it is taken from the cable, whatever may be. From the antenna, it will receive all the signals. So the antenna is positioned in a particular direction. For every television station, there is an angle available. If you keep the antenna in a particular angle, that direction signals will be available if you are using a dish antenna. But you are taking from the cable TV, he will adjust the antenna in such a way that they will tune for your program. So in the antenna, it will there are many signals coming to your tuner. So in the tuner, you are giving the signal in the remote. So this remote will give a particular frequency. That frequency is adjusted in the tuner, so that the particular program is given to the circuit. So in the circuit, so it will separate the video as well as sound. The sound is given to the sound signal track. So where the sound signal is separated. So where the sound is separated and it is given to a loudspeaker. So in the video detector, it will separate them two values. So one it is chroma, another one is luminance. So what is luminance means? How much signal strength is available for each of the color signals. So chroma is how much content red color signal is available, green color signal is available, blue color signal is available. So in a color TV, you have seen different colors. So red, green, blue are the primary colors. Red, green, blue are the primary colors. So other colors are produced by the combination of these three colors. Okay? Only three colors are primary colors. Remaining colors are produced by the combination of these three colors. For example, red and green you mix, you get another color. But green and blue, it will get produce another color. So if you mix three colors, you get another color. So red, green, mixed color with blue color, you get one more color. So all the colors can be produced by these primary colors. So in a picture tube, color picture tube, so only three guns, electron guns. So in the monochrome receiver, in the monochrome picture tube, we have only one electron gun. It is only black. So it will emit an electron consists of a black. So wherever that electron beam hits the monochrome TV screen, there is a white signal. Otherwise it is black. Here there are three electron guns, so it will produce three colors. So in the phosphor coating of the screen, for every dot, there are three single dots for every electron gun. Okay? So in the monochrome TV receiver, monochrome picture tube, you have a single dot. Every screen is divided into several dots. The electron beam hits the dot, white color is displayed in the color picture tube. So this color picture tube is also divided into several dots. Every dot is separated into subdots, three subdots. So three subdots, so every subdot is allocated to a particular gun. It may be a red gun, or a green gun, or a blue gun. Okay? So if red gun and green gun is only pointing that the dot means it will produce one color. If the percentage level of red and green varies, means some more color will be produced. Okay? So this color signal information are taken from the chroma signal filter and it is given to the chroma subsystem. The chroma subsystem will separate the red color, green color, blue color, and it is given to the red, green, blue gun. So this luminance means how much signal strength. Red color, how much percentage it is. For example, it is 50% red. Green color is 70% red. Blue color is 20% red means. So the corresponding signal strength is given by the video amplifier. So when you add this red color, green color and blue color signal strength, it should be 100. Red may be 30, green may be 50 and blue may be 20. So it is one combination. So this may be any combination, but when you add the signal strength of red, green and blue, it should be 100. It should not be exceed 100. So this chroma subsystem will separate the color signals and it will give the color signals to the corresponding guns. Red, green and blue guns. Here also you have focusing anode, controlling anode, accelerating anode, deflection coils, etc. This is available for every gun. Not only for it is not for all the guns. It is available for each gun. So similarly, in a dot in the screen, it has 3 small dots for every electron gun. So when the 3 electron guns hit these single dots, depending upon the strength of each of the signal, so it will produce a particular color. Okay. So here the video is very complex. You have to separate the signal strength of the RGB and you have to take the RGB colors also. Then only you have to give to the picture. So in transmission, while during transmission, whether it is a color TV or monochrome TV, the operation is same only. Okay. So transmitting procedure is same, whether it is a monochrome TV or a color TV. For receiving, television receiver is different for monochrome TV as well as color TV. Picture tube also different. So synchronization. So synchronization means, so you have to synchronize both the sound wave as well as the video signal. Similarly, so the signals are transmitted via free air. It is receiving by the received antenna. The signals are come to the circuit. So there should be a perfect synchronization between the scene televised and the picture produced on the raster. Raster means screen. So what the television station is transmitting and what is the picture producing on the TV should be synchronized. Then only you get a perfect image. If there is any delay, you get a scattered image on your TV. Nowadays it is not possible. In olden days, if there is a delay, so sound will come before or sound will come later. This type of problems occurs in the television. So the next one is receiver controls. So first one we see about the black and white TV. So in the black and white TV, first control is channel selector. So you have to select a channel. So channel selector, it may be in remote type. In olden days there is a knob, rotating knob. You have to rotate the knob to select to a particular frequency. So another control is there which is called fine tuning. So fine tuning means, so channel selector will select a channel. Sometimes there may be some noise may occur in the television due to the frequency mismatch. For example, the frequency of television is 90 megahertz. So I have tuned to 89.8. Then I have to fine tune to 90 megahertz. So there is a control available in the television. It is used to adjust the frequency to the particular frequency. Fine, that is known as fine tuning. Next one is brightness. So brightness means how much amount I am increasing the white color. So if I increase more white color, the image will become more bright. So for this there is a rotating knob will be available. So you can increase the brightness level. Next one is contrast. So here also, how much amount of white level? You have to reduce the difference between the white level and the dark level. So this can be done by the contrast button. Next one is horizontal hold. Sometimes if you see some televisions, the image will go very fast up and down. For this, you have a control button, horizontal hold, and you can adjust that, and you can make the screen steady. You can make the image steady. There is a button available in black and white TV that is called horizontal hold. Horizontal hold. Apart from this, you have volume controls, on and off switch, etc. We see one by one. Channel selector which is used to select the particular channel. Fine tuning is provided for obtaining the best feature details in the selected channel. So if you see some olden TVs, you have to change the antenna position in order to get the best image. Nowadays it is not necessary. You have to adjust the frequency alone. It is since it is digitized, we can adjust the frequency to get the particular channel very fine tuned. For brightness control, there is a beam intensity of the picture tube. So contrast control will increase the control of the video amplifier. So it will boost the signal, contrast control. Brightness control will increase the electron beam intensity. It will increase the strength of the electron beam intensity. That is the difference between the brightness and the contrast. So contrast means you can vary the difference between white and black contents of the reproduced picture. If you reduce the difference between white and black contents, it will be more brightness. So hole control is used to get a steady picture in case it rolls up or down. Sometimes the picture will be rolled up continuously or rolled down continuously. You can hold the hole control button and you can make it steady picture. So volume and tone controls is forms of the audio amplifier and used for setting volume and tonal quality. So in color receivers, you have additional control called color or saturation control. So this will increase the this will color control will increase the signal strength of the red gun, blue gun, and green gun. So automatically your color will have more darkness. So that is known as color control. Next one, it is used to vary the intensity of amount of colors in the reproduced picture. So in modern controls, in some receivers, hole control is not necessary, so it is not provided. So aspect ratio. So aspect ratio is you take a television, you have a width, you have a height. So the width bar height ratio is called aspect ratio. So when you are seeing a television, the motion occurs only in the horizontal plane. So if you see a television, normal human eye will see the motion only in the horizontal plane. So you want a larger width TV. If you look at a TV, when you buy any TV, whether it is a 32 inch or 48 inch, whatever TV, you have a larger width when compared to the height. So it is not necessary that size of the picture produced on the receiver screen is same as that of the televised. So in the broadcasting television station, it will televised in a bigger frame. But in our TV, it's a smaller one. So we are buying a 22-inch TV. Some portions of the screen image will be deleted on the side. So you have to change the mode accordingly so that everything should come inside. If you have a portable TV, some persons have seen the portable TV, it is 14-inch TV. So in that most of the portions of the image will be cut off. So the actual image televised by the broadcasting station is very high. The television is very small. Okay. So we have to adjust the coils, deflection coils, so that the image received from the television station as well as the TV should be equal. For this, we have the modern televisions, we have different modes, theater modes, and so many modes. So you can change the mode so that all the components should be all the image will be come inside the television. In olden TVs, it is not possible. So this is about the uh, TV transmitter, television communication. So this is a camera tube. So in the television station, you have a camera to record the video. So this is color camera tube. If it is a monochrome camera tube, you have a single lens and single tube. Since it is a color camera tube, we have three lenses and three pickup tubes. So we are taking all the lights. The camera will take the light from the screen and it is given to three mirrors. So these mirrors will transmit the image to the particular filters. They are optical filters. So that filter will filter only the corresponding component. The image contains all the colors, but the R filter will produce the output of only R component. G filter produces a component of G component. B filter will produce a component of B component. Then it is given to the corresponding pickup tubes. Then it is given to the voltage. Then it is combined and it is transmitted. So from the transmission side itself, the camera captures color in terms of RGB. So the picture tube also transmits the color in the terms of RGB. These RGB are primary colors. So this is about television communication. So next one is optical fiber communication. So optical fiber communication is a method of communication used for transmitting the information. So it is used by the telecommunication company. So they are using the light to transmit the images. So they are not taking a light as it is. They are transmitting the light as a continuous pulses of light by sending a continuous pulses of light through an optical fiber. Okay. So optical fiber is a dielectric waveguide that operates at optical frequencies. So this optical fiber is a cable. So inside the cable, you have a glass type cable. It is a glass type cable. So it has some wires. So inside the wires, the signal is transmitted. So that wires will transmit the signal in the form of light. So the light will totally internally reflected and it will move to the next location. So the function of the optical fiber is it will transmit the electromagnetic energy in the form of light to within its surface and guides the light in a direction parallel to its axis. So this optical fiber cable is a long cable. So inside the long cable, it is a glass cable. So lights are reflected from 90 degree. So it will be reflected to the top and reflected to the bottom, outside reflected to top, bottom, and continuously it will be reflected and it will reach the other end. Okay. So what is the principle in the optical fiber cable? So here we seen that it is a totally internal reflection. So we are calling as a light propagation method. So what is the principle of light propagation method? So when a light ray is incident on a interface, so there is an interface N1, so there is a line, so light is hitting on the line. So below that it is N1, above that it is N2. When a light ray is incident on the interface between two mediums, here there are two mediums, N1 and N2, having different indices. So refractive index is different for different mediums. Then an angle greater than the critical angle, then the light gets totally internally reflected within the medium of higher refractive index. Okay, here there is a medium, here there is another medium. This is the interface between these two mediums. When you transmit the light with an angle greater than the critical angle, then it will be reflected back to the same surface. Okay. The condition is this surface should have the refractive index more when compared to N2. N1 refractive index should be more than N2. Then it will be totally internally reflected. So here it is incident, it is hitting here. So once again it is reflected back. So here another material, here once again it will be reflected. This will continuously moving. Okay. So refractive index, the refractive it is low index, it is high index, then it will reflect it back. If it is high index, it will go here. So the refractive index of glass is high when compared to the gap. So it is totally internally reflected here. So the phenomenon of total internal reflection occurs at the interface between two dielectrics of different refractive indexes. Only the light is incident on a dielectric of lower index from the dielectric of higher index. So glass is of higher index, air is of lower index. So light is incident on the dielectric of lower index from dielectric of higher index. Second condition is the angle of incidence should exceed the critical value. There should be a certain angle, it should exceed the critical value, then only total internal reflection will occur. There are different types of fibers are used for optical fiber cable. There are step index fiber, single mode, multi-mode, graded index fiber, this is repeated. Okay, step index fiber, there are two parts, single mode, multi-mode. Graded index fiber, it is only multi-mode. So step index fiber, refractive index of core is maximum and it is constant. So this is the value for the refractive index of cladding. So what is cladding means? The glass is a very thin material. It will break during operation or handling the glass. Then you have to provide a protective mechanism. So mechanical protection is necessary. Then so you are keeping some material, rubber tube over the glass material. So that the rubber material has a different refractive index. That is given as cladding. This is about multi-mode fiber. This is not needed. So general working overview of optical fiber communication system. So how this optical fiber communication system works? So you have a source of information. So it is electrically transmitted. So before it is transmitted to optical fiber, it is the source of information in electrical form should be converted into optical form. That is known as optical source. Then you have to transmit the light through the optical fiber cable. So at the receiving end, there is a photo detector which will receive the light and it will convert the light into electrical signal. Then it reaches the destination. So this is the overall flow diagram. So information is electrical signal. So you have to transmit the electrical signal to the starting end of the optical source. So in the optical source, the electrical signal is converted into optical source, optical information. It means the electrical energy is converted into light energy. So after conversion, it is transmitted to optical fiber cable. So in the receiving end, there is a photo detector. This photo detector will receive the signal and it will receive the signal and it will convert the electrical signal into say light signal into electrical signal. Then it is reaches the destination. So what are the elements in the optical fiber communication system? So there is a transmitter, there is a regenerator, there is a receiver. These are the three main parts. So why a regenerator is required? So during the transmission, the light energy may be degraded. So the light energy may reduced. So in order to boost the light energy, we are using a regenerator. So regenerator as a optical, so it will convert the optical information to electrical information. Then once again it will convert the boost the electrical information. The signal strength is increased and once again it convert to optical information. This process is done in the regenerator. So in the transmitter, the electrical information is converted into light energy and it is given to the fiber optic cable. So in the receiver, there is a photo detector and the amplifier and the electrical signal is generated. Photo detector will convert the light energy to electrical signal and amplifier will boost the voltage and it is given to the necessary circuit. So what is the benefits of this optical fiber communication system? So the bandwidth is effectively utilized. Bandwidth means the frequency spectrum. So for example, 50 to 500 hertz frequency spectrum is effectively utilized. So electrical isolation is very good in the transmission medium. There is no interference because it is transmitting light. So other signals are electromagnetic waves. The electromagnetic waves cannot interfere with the light. So there is no noise in the optical fiber cable. So whatever signal you are transmitting, it is free from noise. So total electrical isolation is available in the optical fiber communication. Next one is very low transmission loss. Light energy is transmitted. So the loss is also very minimum. The size of the cable is very small. It is very lightweight. When you take a coaxial cable, in olden days telecommunication people will use coaxial cable. So it is very strong. It is heavy weight. So but the optical fiber cable is very lightweight. Size is also small when compared to a coaxial cable. So signal security is very good. So you cannot interfere with the light energy and you cannot cross the code in optical fiber communication. So interference crosstalk is nowhere available. Power consumption is very less and it is useful for very different applications. There is no disadvantages also in optical fiber. Only disadvantage is it is very costly. It is very costly. It is difficult to maintain. Maintenance cost is also very high. So if there is no problem, it is okay. If there is a break in the circuit, if there is a break in the optical fiber cable, you have to replace a huge portion in the optical fiber cable. So the operation cost, installation cost, and maintenance cost is very high in optical fiber cable. Due to the variety of advantages of optical fiber communication system, it has wide range of applications in different fields, namely public network field, which includes trunk networks, junction networks, local access networks, submerged systems, synchronous systems. These are all things are related to telecommunications. Okay. So next one is military applications, consumer applications, industrial applications. Consumer application means that nowadays we have seen, so I have put a telephone connection by optical fiber. Some private company X and Y are putting a telephone connection by optical fiber for rupees 700 and 800. It is one of the consumer applications. So industry people are using this fiber optic to transmit their data. Sometimes civil purpose they are using this. So in the research center, in order to protect the data during transmission, they are using this optical fiber cable. So this is a working of the optical fiber communication system. The coaxial cable method is slowly moving out. It is slowly going absolute. So optical fiber only they are now installing. Landline connection is mostly optical fiber connection nowadays. So earlier days it is coaxial cable. It has more power loss. It has more noise. So a lot of problems in their coaxial cable. So they are slowly moving to optical fiber communication. So next topic is satellite communication. So satellite communication, how it is working, what are the types of satellite communication, how much customer you can connect to the satellite. So how the satellites are working? There are two stations on the earth want to communicate through radio broadcast, but are too far away, then you have to use conventional means. So if there are two earth stations, we want to transmit the data through radio means it is very difficult. For this purpose, we are using the satellite. So one station will transmit the data to the satellite. The satellite will receive the signal and once again it will transmit to the other station on the earth. So one earth station will send the transmission to the satellite. So this is called uplink. So first the information is taken from the earth station and it is transmitted to the satellite. Satellite will not produce any data. Okay. So all the data are coming from the earth and all the data are receiving to the earth. So one earth station sends the transmission data to the satellite. This is called uplink. So in the satellite, you have a transponder circuit that will convert the signal, that they will boost the signal or attenuate the signal or change the frequency, and it once again send back to the second earth station. For this communication, we are calling as downlink. Okay. So in any satellite communication, there are two links. One it is uplink, other one is downlink. So one starting one earth station, transmitting earth station to the satellite is called uplink. Satellite to the receiving earth station is called downlink. So advantages of satellite communication over this radio communication or television communication is, so it will the coverage area of the satellite is very high. So it will exceed the total area of the galaxy, total area of the planet. We say it is total area of the planet. So the total exceeds the data of a terrestrial system. The transmission cost of a satellite is independent of the distance from the center of the coverage area. So if it is transmitting by a satellite, if it is small distance, same cost only. If it is a larger distance, it is same cost only. Satellite to satellite communication is very precise. So when you are using satellite for communication, it will be clear communication. There is no noise. So it will produce accurate data. You can go for higher frequency range. Higher bandwidths are available in the satellite communication. So disadvantages of satellite communication are launching satellites into orbit is costly. Satellite bandwidth is gradually becoming used up. So first you have to launch the satellite in the space. So designing the satellite is costly. Launching the satellite is also costly. You have to properly place the satellite in the orbit. Satellite bandwidth is gradually becoming used up. So a large number of satellites are revolving around the space. So that frequency range is slowly reducing. So a larger propagation delay in satellite communication than in terrestrial communication. So the propagation delay is high in satellite communication when compared to radio communication or television communication. Even though propagation delay is high, but it will be, the image is very clear. So elevation angle. What are the factors very important means? So there is a earth station, two earth stations. One it is transmitting one, another one is receiving one. You have to properly place this earth station. The angle of this earth station should be properly placed. The angle of the horizontal of the earth space to the center line of the satellite transmission beam. So you have to place the angle so that it is to the center line of the satellite transmission. Then only it is satellite is capable of detecting the signal. This calculation not needed because you have only theory parts. So there are different types of satellites. Service depending upon the service types, there is fixed service satellites. So it is used by a certain people, point-to-point communication. It is used by a industry. For example, it is used by a particular country. Then it is known as point-to-point communication. Next one is broadcast service satellites. This is used as satellite used for television, radio, etc. We are calling also direct broadcast service. Another one is some mobile phones using the satellite for communication. That satellites we are calling as mobile service satellites. These satellites are placed in the orbits. Different orbits are available the space. So depending upon this orbit, we are classified as geo satellites, LEO satellites, MEO, multi-orbit apps, and depending upon the frequency bands also, we are separating the satellites. So geostationary Earth orbit, GEO, geostationary Earth orbit. So these satellites are in the orbit, which is 35,863 kilometers above the Earth's surface. It is in the equator region. So these satellites revolve at the same speed of the Earth rotates. This means LEO satellites remain in the same position relative to the surface of the Earth. Okay. So whatever the day, so the relative position between the Earth and the GEO satellite is same. So it is kept at an orbit of 35,863 kilometers above the Earth's surface. It is in the equator region. So advantage is geosatellite distance for the Earth. So it will give you a larger coverage area, almost a fourth of the Earth's surface. So it will cover whole Earth's surface. Apart from this, it will cover other three types. So geosatellites have a 24-hour view of a particular area. So it can capable of handling all the area for 24 hours. So this is used for broadcast applications and multi-point applications. Geo satellite disadvantage is the distance. So if the distance is increased, the signal is weak and the time delay is also increased, which is bad for a point-to-point communication. So another problem is that since it is centered above the equator, these satellites are not capable of sending the signals very good in the polar regions, cold regions. It is difficult to transmit signals to the polar regions. Next one is low Earth orbit. Low Earth means the distance is very low. LEO satellites are much closer to the Earth than GEO satellites. It is about 500 to 1,500 kilometers above the surface. So these satellites will not remain in the same position. They will be continuously rotating. Every 15 to 20 minutes, it will change its position. So a network of LEO satellites is necessary in order to work it. The advantage is it is very close to the Earth, so it will produce a better signal strength and the time delay is reduced. So it is used for point-to-point communication. So, but the coverage area is very, very less in LEO satellites. So disadvantage is in a network of LEO satellites is needed, so it is very costly. So these LEO satellites are continuously changing its position. So you have to compensate this position. So atmospheric drag will affect the position of this LEO satellites. Next one is MEO. It is called medium Earth orbit satellite. It is between 8,000 to 18,000 kilometers. It is similar to LEO in function, but it is visible for more than 8 hours. 2 to 8 hours, it is in the same region. After that, it will change its position. So it has a greater coverage area than LEO satellites. So MEO satellites have longer duration of visibility. Fewer satellites are needed for the MEO network. MEO satellite distance gives a longer time delay and weaker signal than a LEO satellite. So Molniya orbit satellite here also a series of since 24 hours of the day, they are using three Molniya satellites right as a GEO satellite. For GEO satellite, you require only one satellite. For Molniya, they are using at least three. For MEO, you have to use at least four, not four, at least 7 or 8. For Leo, you have to use at least for 20 minutes you have to change. So you have to use 24 into 3. 72 Leo satellites are required for operation. So this Molniya orbit is very good in polar regions. So high altitude platform, it is very high. It is only 20 kilometers above the Earth surface, used as a satellite. It covers only small coverage area, but the signal is very strong, cheaper, but lot of work has to be done. Then, according to the frequency bands, these satellites are separated. So, L band, S band satellites, C band satellites, X band satellites, KU band, K band, Ka band. So, L band is the frequency 1 to 2 gigahertz. It is used by MSS. And S band 2 to 4 gigahertz, it is used by NASA, Deep Space Research, etc. C band, it is 4 to 8 gigahertz, it is used by FSS. 8 to 12.5 gigahertz X band, it is also used by FSS. KU band 12.5 to 18, BSS and FSS. K band 18 to 26.5, FSS and BSS. And Ka band 26.5 to 40 gigahertz, it is used by FSS. So what are the techniques used for communications? Frequency division multiplexing technique or time division multiplexing technique. So in the frequency division multiplexing technique, so frequency allocation or time allocation method are used. For satellite frequency, there is a particular frequency range for particular band. That particular frequency band range is divided into small frequency bands. That is smaller channels. That is known as frequency division multiplexing technique. For example, I have a satellite frequency of 0 to 100 Hz. So I am dividing this 100 Hz into 10 parts. 0 to 9, 0 to 10, part 1, 11 to 20, second part, 20 to 30, third part, 40, 30 to 31 to 40, fourth part, like this. I am dividing the frequency into smaller channels. Then I am assigning this channel to a particular satellite. This method is called frequency division multiple access technique. So overall bandwidth, the frequency band is increased due to the frequency reuse. The number of subchannels is limited by 3 factors. One it is thermal noise, and one is intermodulation noise, and one is crosstalk. Number of subchannels, how many subchannels a particular satellite can transmit. So it depends upon the factors. So thermal noise, heat effect is a problem. Then intermodulation noise, so noise will cause a problem. So if you are using the frequency many times, excessive frequency reusing, then it is equivalent to a crosstalk. These are the 3 problems that is occurred when you are using a frequency division multiplexing technique. So in the frequency division multiple accessing technique, there are 2 methods. So one it is fixed assignment and one is demand assignment. So fixed assignment means there are different satellite televisions. They will give a particular frequency for a particular television. That is known as fixed assignment multiple access technique. Demand assignment multiple access technique means whenever a television station asks for a demand for a particular month, we will allocate a channel. Otherwise, that channel will be free. So that is known as demand assignment. So this fixed assignment is used for broadcasting. for television, mobile communication, etc. For demand assignment, it is used only for point-to-point communication because it is used by a certain people for a certain time. Next one is TDMA. It is known as time division multiple access. So in the previous example, we are dividing the frequency into several slots. Here the time is division into multiple time slots. Each one is dedicated to a different transmitter. TDMA is increasingly becoming more widespread in satellite communication. The TDMA uses the same technique as that of FMA and DMA. What is the advantages of TDMA over FDMA? So digital equipment used in time division multiplexing is increasingly because it is very cheap. So error correction is very easy in TDMA. The noise is very less in TDMA, and efficiency is improved. So this satellite communication is mainly used by the telecommunication system to communicate with anyone and anytime. So satellite is evolving all the 24 hours. Before the telegraph and telephone, all the communications are done by face to face. Then they write a letter and it is given by post in the early days. Then if you want to talk to someone, you have to travel and to meet with that person. Otherwise, you have to write it down and you have to send the papers and it is sent by a carrier. Next came the telegraph cables in the 1800s. It is not in India, in Western countries. So in the telegraph cables, telegraph system used copper wire, that is known as coaxial cables, to carry the signal over the earth's surface and also across the oceans. But this voice signals only begin in 1953. Before that, it is only signal transmission only. For 150 years, it is only signal transmission. The voice transmission is not made. So in 1945, high frequency radio was used for communication for one continent to other continent. This high frequency is also called a short wave. If this frequency is high, means the wave is short wave. So it is 3 to 30 megahertz, but it is not reliable because due to the atmospheric disturbances, so it will affect the radio link. So the satellite communication start in 1945 by a British person, Arthur C. Clarke. The Clarke suggests that a radio relay satellite in an equatorial orbit, the period of 24 hours, remains stationary with respect to its surface will make a long distance radio links. In 1945 itself, we have found out that we keep a satellite on the equator position, then it will be used for 24 hours. You can communicate for 24 hours. For implementing, he had found out that it is possible. So at that time, there is no rockets to launch this. He also wrote that there were no rockets to launch this. So in 1957, satellite communication began in 1957. So Russia only sent the first satellite. It is very small. It is called Sputnik 1. So it is a first artificial satellite. So it is kept placed between US and Russia. So Sputnik 1 only carried a beacon transmitter. So it is not effective. So it does not have the capability of receiving the information from the Earth satellite. So it will transmit the information. Whatever information it is gathering, it will transmit. That is property is available in Sputnik 1. Next, USA launched their satellite, which is called Explorer 1 in 1958. So another satellite is sent, that is known as core satellite. So in this satellite, they are sending a voice call, Christmas message, and it is once again received back in the earth. So first commercial communication satellite. Commercial communication satellite means television, mobile, etc. So the telecommunication is satellite was named as Intelsat 1. In 1965, it is launched. So it is in the orbit of 22,300 miles above the equator. So the satellite is about 36 kg. So this helipad doesn't have a battery. So only if solar panels work, this will work. So it depends upon the solar panels. So satellite communication, first passive communication satellite is launched in 1960. So passive means it is not bidirectional. That is not passive. The active communication satellite is installed in 1962. The geo orbit satellite, first satellite is launched in 1963, but it is failed. So in 1964, this International Telecom Satellite Organization, Intelsat, they have launched the same company, they have launched another satellite, Intelsat 1. First domestic satellite is launched in 1972. First successful direct broadcast experiment is done in 1975 by USA. So direct to home broadcast system, television system satellite is launched in 1984 by Japan. So mobile communication satellite is launched in 1987. So it is continuously increasing. Nowadays, there are a lot of satellites in the orbits. So what is a satellite? Satellite is a celestial body that moves around a planet. So moon is a satellite of a Earth. Similarly, satellite rounds the Earth. So it is moon rounds the Earth. So we are calling moon is a satellite of the Earth. In aerospace terms, satellite is a space vehicle launched by humans, and it is move around the Earth or another celestial body. So it is not necessary to move around the Earth. It can also make it to move around the Mars, Jupiter, any planet, any celestial body. So communication satellite, it is a microwave repeater in the sky. So it will receive the signals from the Earth station and it will amplify, and once again it will transmit to the another Earth station. So the satellite radio repeater is called transponder. It has transmitter and receiver. So first Earth station will transmit the signal. So it is received by the satellite. It is called uplink. Now it is changing the frequency. So once again it is transmitting the data to the another Earth station. Advantages is global availability. It is available all the 24 hours. It is available all around the world. So that is the big advantage in satellite communication. So cost of the satellite capacity does not depend upon the number of users and the distance between the communication points. Only thing what you are deciding in the beginning, that is only the cost. Reliability is very good in satellite communication when compared to other communication. Scalability means you can increase the number of users. That is known as scalability. The performance is very good. It is superior performance when compared to other communications. So disadvantages, initial cost is very, very high, large and expensive when you are building a new satellite. The propagation delay is very high. So you cannot repair and maintain the satellite. If a satellite fails, you can make the satellite to revolve around the orbit, or you can send another satellite to demolish the satellite. So you cannot repair and maintain the satellite in the space. The noise and interference is high because of the number of satellites are increasing nowadays. So what are the applications of these satellites? It is used for video conferencing. Nowadays, this video conferencing is went to a huge level. Radio broadcast, TV broadcast, nighttime loading and receiving, and online education, then talkback channel, webcam, return link, asymmetric internet through EVRO. This orbit is called equatorial orbit. This angle is called inclined one. This is known as polar. If it is this orbit, we are calling as equatorial. It is inclined. Here it is known as polar. LEO is about 1000 kilometers. Revolution time is 3 hours. You have seen this. The medium orbit is up to 20,000 kilometers. And the GEO is up to 35786. So for GEO satellite, you require 3 satellites. So the typical service of this satellite is service time is 10 to 15 years. So we have already seen this. So this medium orbit, the altitude is 8,000 to 20,000. Revolution time is approximately 6 hours. These orbits are primarily served for communication satellites that cover the north and south pole. Unlike the circular orbit of the GS station, the satellites ABOs are placed in elliptical orbit. Reduces transmission delay, low transmission power, smaller coverage area. Network of at least 6 layers satellites are required to cover a region. So this is all about satellite communication. So from morning we have seen what is amplitude modulation, what is frequency modulation. We have seen the radio communication. We have seen the television communication, microwave communication, fax mail communication, then optical fiber communication as well as satellite communication. All the communications are used to transmitting the information. It may be a individual communication or it may be a broadcast communication. So this is our last unit, 6 types of communication. You have to explain the block diagram. You have to explain the working of the communication. Only theory. There is no problems in the last unit. Last unit means unit 5. Model 3, unit 5. Is there any doubt? If you have any no doubt, I will ask. If you have any doubt, you can ask me. Ivan Joseph.
Yes, sir.
What is the difference between amplitude modulation and frequency modulation?
Sir, in the amplitude modulation, the amplitude of the signal is modified, and the frequency modulation, the frequency of the uh, this mode is modified.
Frequency is modified. Very good. Ivan Joseph, next Kirtivasan. 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 Melvin Thomas. Melvin Thomas. What are they doing? They are keeping the phone and run away. Prasant. Prasant. Yuvraj. Yuvraj. Vishwajit. Hello.
Sir,
Is there any advantage in satellite communication? What is the main advantage in satellite communication?
advantage in sir. Sir, once again,
What
sir.
is the main advantage in satellite communication?
Sir, we can cover a wide area, sir, in the satellite communication.
It can cover a wide area. Very good. Okay. Prasant, come in chat. So I will ask a question in chat. What is geo satellite? Abbreviation for geo satellite. Geo satellite abbreviation. Prashant, tell me. I will stop recording.